All right, the secant function, which is the what we call a sec. Okay, so y equals sec x, which is y equals 1 over cos x. So it is the reciprocal of cosine. Okay, we're going to look at the type, domain, range, period, and amplitude of secant, sec. Okay, all right, so it will look like this. Unfortunately, I can't really show you the whole beautiful graph, but you will actually find out in a, I don't know if you use the Desmos or something like that. Anyway, so let's have a look at this. Now, of course, we will have asymptotes again, because we cannot divide it by 0, which means cos x cannot be 0. Wherever the cos x is 0, you will have asymptotes, which is pi over 2, 3 pi over 2. Okay, so this is a 30, 45, and 60, and that's 90, that's 120, 135, 150, and 180. Okay. So again, I'm just going to put cos 30 is root 3 over 2, which is reciprocal of that is 2 over root 3, which is roughly 1.2. Now cos 45 is 1 over root 2, reciprocal of that is root 2 and 1.4. And cos 60 is what? Half, and the reciprocal of that is 2, and it's 2. So it's actually getting bigger. So I'm going to go from here all the way to big, because cos 0 was 1, so it'll be just 1. Okay, 1 over 1 is 1. So I'm going to put that in there. And of course, if we look at this one, so what's this one? 120. That's cos 120 is same as cos 60, negative cos 60, which is minus half, which is minus 2 if you do reciprocal, and minus 2. And cos 135 is negative cos 45, which is minus 1 over root 2. Reciprocal of that is minus 2, and roughly minus 1.4. And 4 pi over 6 is 150. That's cos minus cos 30, which is the same as minus root 3 over 2. Reciprocal of that is minus 2 over root 3, and roughly minus 1.2. So here it's getting sort of bigger number to getting smaller. So it's going like that and going to. So this is what it looks like. And I'm going to have a look at domain. Yeah, it looks, you can get through anything except for where it hits the asymptotes, right? And range will be similar. From here on, there's nothing happening between 1 and minus 1, because there's nothing there, because this dotted line is actually cos x. Okay, and period will be roughly from here, that, and that one, and this. That's one pattern. So it's 2 pi. We have no amplitude. All right, let's have a look at the type of that. So what I'm going to do is I'm going to do the same here. Sec 60 equals, let's have a look at sec 60. Sec 60 is what? Oh, here, half, which is, well, reciprocal of that will be 2. So I'm going to get 2 here. And then sec negative 60. If I go to 60 here, negative 60 all the way up, I will get also 2 here, because it's a positive. So that's a classical case of even function. So I'm going to call it even. Oops, it's a bit dark in here. So even. Why? Because it looks like negative sec 60 degrees. Okay, and domain, of course, domain will be negative infinity to infinity, except when x equals pi over 2, 3 pi over 2, and so on, because that's where asymptotes are. Range, same as with the cosine, so it'll be negative infinity to 1, negative 1, and then a 1 to positive infinity. Period 2 pi, no amplitude. Okay, so this is a secant, which is y equals sec x.